board previously? Yeah. Let me do this and then we'll figure it out. Yeah, when we're done. Of course. So, guys, 7.3 talks about repeating decimals. So repeating decimals are obviously when you're doing a division problem and you're doing this like on your calculator and you get a number that keeps repeating. So the first part here says do 0.45 3/7 with a bar, 0.45 2/7 with a bar, and 0.57 with a bar represent different numbers. Okay, so what I want us to understand, y'all, is when we have that little bar just means that the number is repeating, right? So if I were to think about, say, this one here would be the same thing as 0.5, and I'm just going to start writing like a ton of sevens, right? And I know that they're going to go on forever, right? And if I do 0.577 with the bar, wouldn't that mean that the 77 is going to repeat? We're going to keep going. And 0.537 with a bar, doesn't that just mean that the 3 sevens are going to repeat? Okay. And y'all, if I look at my numbers here, remember the little dots just mean I'm going on forever. These all look like the same number, right? There's nothing really any different because in essence, what's the number that's repeating is the number 7, right? So do they represent different numbers? No, they don't represent different numbers. The only difference is that the repeating block of sevens is indicated in different ways. So then the second question says, which is the preferred form? Which is the one that we want to write, if they all really mean the same thing? So y'all, the way we really want to write this is just with the 7 being repeated, okay? Because since the 7 repeats, it's really kind of redundant to put 77 repeating because what's repeating? The number 7 or 777, right? So it really is just write a single 7 with the 7 repeating, okay? And then, y'all, I have another little piece right here, and it says the period of a repeating decimal is the number of digits which repeat, okay? So what's the repeating part here, or what's the period? The period would say how many digits, sorry, let me get my pen going here. How many digits are repeating? Well, just that one digit, right? The one digit, the 17 is the number that's repeating, okay? So let me go ahead and keep going here. And okay, so this first part here, y'all, says find a decimal representation of 94 divided by 99. So what I'm going to do here, y'all, I'm going to take my calculator. Let me clear this out. Okay, and I'm going to take 94 and I'm going to divide it by 99. And I want you to notice what I have here. I have 0.949494. Okay, so let me go ahead and see if I can look at this. 0.949494, right? So on and so forth. So what number is repeating here, or what numbers are repeating? Wouldn't it be the 9 and the 4, right? So if the 9 and the 4 repeating, y'all, that's when we use the little bar. The little bar just indicates that those two digits are repeating, right? Because again, it kind of goes on and on and on forever. All right. So the next problem that I have here, y'all, says convert the repeating decimal to A over B form when A and B are integers and B is not 0. Okay, so I want to walk y'all through this process, y'all. What I want you to notice here, there are two digits that are repeating, right? Because the bar is over the 8 and the bar is over the 1 itself, right? So it's 81, 81, 81, 81. Okay, so y'all, there's a process on how we're going to do this. When I multiply by powers of 10, what I mean by that is if I multiply by 10 or 100 or 1,000 or 10,000 or 100,000, in essence, what happens, y'all, is my decimal place moves a certain number of points, okay? So look, let me show you what I mean by that. Let me take a number like 0.2365, okay? I'm gonna multiply this number by 100, okay? And I want you to notice what's gonna happen to my decimal point. So if I multiply it by 100, notice my decimal point moved 2 spaces. It used to be in front of the 2, and now it's in front of the 6. So I moved it 2 spaces, okay? So look, let me take that same number, 0.2365. Let me multiply it by 1,000. And I want you to notice what's going to happen. It moved it 3 spaces, right? So this is the idea, y'all. When I multiply by 100, I move my decimal place 2 spaces. If I multiply it by 1,000, I'm going to move it 3 spaces, okay? If I multiply it by 10, I'm going to move it 1 space, right? Okay, the reason why I want to do that, y'all, or at least know that information, is what we're going to do is we're going to say, look, let's pick some number x and let's call it 1.81 with the bar, okay? Now, if I were to take that number and multiply it by 100, what would happen? My decimal point, if I'm multiplying by 100, y'all, my decimal point would move 2 spaces. So I would have 181.81 with the bar repeating, because the 81 is going to keep repeating forever and ever and ever, right? Okay, now this is the idea here, y'all. What I'm going to do is I'm going to take that number 100x, which is 181.81, and I'm going to subtract x, which was my original number, 1.81, both with the little bars, okay? And we're going to end up seeing what's going to happen here, okay? So notice, y'all, those 81s go forever and ever and ever this way, right? And those 81s go forever and ever this way. So when we subtract them, all those decimals really are going to cancel out. So what am I going to left with? At the end, I'm going to have a 0, right? Now, 1 minus 1 gives me a 0 also. And 180 minus is just going to give me 180 right there, right? So if I just subtract those numbers, I'm going to end up with 180, okay? Now, if I look at this piece here, 100x minus another x, that's going to leave me with a 99x, okay? What I'm going to do now, y'all, I'm going to go ahead and divide everything by 99, okay? Okay. And so now, y'all, what I have, I'm just going to kind of do this on the side because I'm running out of room here. Sorry, I didn't put enough space. But I have 180 divided by 99. Y'all, I'm going to reduce this fraction, okay? I'm going to divide them both by 9. So 9 goes into 180 20 times, and 9 goes into 99 11 times. And there's my answer. And look, I can actually check that out, okay? Look, y'all, we can check our answer by saying, look, let's take 20 and let's divide it by 11 and look at the number we get, 1.81818181, okay? Now, what I want to explain, y'all, is the process and how I did this, okay? So, y'all, the first thing I noticed about this problem here was that I had 2 numbers that were repeating. So if I have 2 numbers that are repeating, I'm going to multiply it by 100 because 100 will move my decimal point 2 spaces, okay? If I had 3 numbers that were repeating, I would have multiplied it by 1,000. And if I would have only had 1 number that was repeating, I would have multiplied it by 10, okay? So look, let me show you what I mean by that, y'all. And I'm going to do that in the next problem here, okay? So look, I'm going to look at part A. When I look at the first part of part A, I want you to notice there's 1 digit that's repeating. It's the 2. There's only 1 2 that keeps repeating. So I'm going to say, look, let x be 0.2 with a bar, okay? So now, if I multiply that number by 10, y'all, I'm going to get 2.2 with the bar on that second 2, because remember, what repeats? The numbers after the decimal point, okay? Now, the reason why I want to do that, y'all, is I'm going to subtract these 2 pieces now. So I'm going to say, look, let me take 10x minus an x. 10x is 2.2 with the little bar. An x is, a 0.2 with the bar. So when I subtract here, again, remember y'all, those 2's go on forever. So those 2's are going to cancel out. That's going to be a 0. And 2 minus 0 is just 2. Now, on the left side, 10x minus another x is going to give me a 9x. So I have 9x is equal to 2. So when I divide both sides by 9, I'm going to get x equals 2 over 9. Okay. All right. And look, I'm going to do the same thing for the second part in part A. So look, I'm going to call this, I don't know, I guess it's a little 2 like that. And I want you to notice 2 numbers are repeating. So I'm going to let x be equal to 0.2, right? Since 2 numbers are repeating, y'all, I'm going to multiply everything here by 100. So that's going to give me 2 come on, pen, 0.02 with the bars repeating, okay? Again, y'all, I'm going to do exactly the same thing we did before. I'm going to subtract. I'm going to write 100x minus x, okay? 100x was 2.02 with the bars over the 0 and the 2. X itself was 0.02 with the bars over the 2, okay? When we subtract, again, those decimals are going to cancel each other out. 2 minus 0 is just 2, okay? And let's see, 100x minus another x is going to leave me with a 99x, okay? And what I'm going to do now, y'all, is I'm going to go ahead and divide everything by 99, okay? So I end up with 2 over 99, okay? And again, if you want to say, okay, look, how do I know if I did that right? You can always come back and get your calculator. Say, what's 2 divided by 99? 0.2, and the little 0 and the 2 are repeating, okay? All right, so there's a third part to part A, okay? So let's do the third part. The third part, 1, 2, 3, okay? Again, y'all, I want you to notice how many numbers here are repeating. There's 3 numbers that are repeating, okay? So look, I'm going to write x equals 0.002, okay? Since there's 3 numbers repeating, y'all, I'm going to multiply everything here by 1,000. Because what that's going to do is that's going to move my decimal 3 spaces, okay? So look, my decimal moved, again, if it helps, you can go, 1, 2, 3. But remember, there's still 002, 002, 002, right? Just like we did before, y'all, I'm going to go ahead and subtract. So I'm going to take 1,000x minus an x. Now 1,000x looked like this. Okay. Again, those decimals are going to cancel each other out. That's going to leave me with a 2. 1,000x minus 1x is a 999x. Okay. So when I divide everything by 999, okay, I'm coming up with 2 over 999, right? Okay, so look, y'all, this is what I'm going to do now. I'm going to come back over here, and I'm going to write the decimal equivalents right next to it. So the first one here was 2 over 9. The second one here was 2 over 99. This one here was 2 over 999, right? So what I want you to notice is when one digit was repeating, in this case, the number 2, it was 2 over 9. When 02 was repeating, it was 2 over 99. When 0.002 was repeating, it was 999, right? So again, y'all, if I notice there's 3 digits here, I have 3 9s. If there's 2 digits there, I have 2 9s. If there's 1 digit there, I have 1 9. So when I look at part B, y'all, and I'm going to do part B over here because I kind of ran out of room, and I'm going to say, look, I have 1, 2, 3, 4. So I should have 1, 2, 3, 4 nines, right? If I follow that same kind of pattern, okay? All right, and then part C says, let's go ahead and mentally compute the decimal equivalent. Y'all, I'm gonna do this on my calculator, and I'm gonna say, what's 2 divided by 900? And that's giving me 0.00, and then the 2 repeats after that, right? So part C would be 0.00, and then the only number here that's repeating, y'all, is the number 2, okay? And that's for part C, okay? And just to kind of give you a heads up on how they, I know they told us to mentally compute it, but y'all, what I want you to notice right here, if I look at this fraction right here, and I look at the one that we did in part A, so in part A, we had 2 over 9, and now we have 2 over 900. So that means that I multiply that number there by 100. So when I multiply that number by 100, by 1 over 100, I'm sorry, I'm moving my decimal place 2 spaces to the left, right? And that's why it became that 0.002, all right? But again, you can just do that on your calculator. All right, now the next problem here says, express 1 minute as a repeating part, or sorry, as a repeating decimal as part of an hour. So y'all, I know that 1 hour is the same thing as 60 minutes, right? So we want to say, okay, 1 minute would be how much of an hour? Well, it would be 1 divided by 60, right? Because it's 1 minute out of 60 minutes. So look, y'all, I'm going to take my calculator and take 1 and I'm going to divide it by 60. Okay, and I want you to notice what I'm coming up with. I'm coming up with 0.1 and then the 6 repeats, right? So 0.01 and then the 6 repeats. So I would come back over here and I'd say, okay, which one looks like this? Oh, it looks like, in my case, part C, it looks like that, right? Because only the 6 is repeating. All right. Okay, so for the next one here, it says, suppose A is equal to 0.23 that repeats, and B is equal to 0.342 that repeats. Find A plus B by adding from the left to the right. Okay. So look, y'all, this is what I'm going to do. For the number A, it says it's 0.23 that repeats. So I'm going to do this. Okay, I'm just going to write a few of them. How many is a few? I don't know. I wrote 1, 2, 3, 4, 5. I wrote 5 of them. Okay, let me do the same thing for part B. 0.342. Okay. 42, 342, 342. Okay. And now it says, by adding from the left to the right. Okay, so A plus B. Let's see. That's still 0. 2 and 3 is 5. 3 and 4 is 7. 2 and 2 is 4. 3 and 3 is 6. 2 and 4 is 6. 3 and 2 is 5. 2 and 3 is 5 again. 3 and 4 is 7. 2 and 2 is 4. Okay. 3 and 3 is 6. Okay, I'm going to write a few more, y'all, because I want to make sure that I'm doing okay here. So I'm going to go 23, 23, 23. And what number was I adding? 342. So 342, 342, 3. Okay, let me keep going here. 2 and 4 is 6. Okay. 2 and 3 is 5. Okay. 2 and 3 is 5 again. 3 and 4 is 7. 2 and 2 is 4, and that's 6. Okay. So y'all, what I'm going to start doing, I'm looking to see if I see any kind of a pattern. So 0.574665, 574665, 574. Okay, so it looks like these are the numbers that repeat. So 0.574665 is what's repeating, and that's exactly what I have for part C. So, y'all, all they were really wanting me to do for this problem is just write out a few of them, okay? And start looking for a pattern. again, y'all, when you start teaching elementary school kids, like, are you actually going to do this problem? You're not really going to do this problem with your elementary school kids. But what you're going to do is you're going to try to show them patterns, right? And that's going to kind of be the idea. All right. So y'all, like I said before, and I'm going to just pull up something here on Blackboard real quick, y'all. So let me see. Let me back up real quick. I'm going to scroll up to the top for a second. But right here. So y'all, when you're working with your kids or your students, whatever, you're going to be looking for patterns, right? So again, when if you end up, say, with a second or third grade class and you're showing them the multiplication table, 2, 4, 6, 8, 10, right? You're showing them little patterns. And you're saying, look, 2, 4, 6, 8, 0, 2, 4, 6, 8, 0, 2, 4, 6, 8, 0, right? And you're going to show them patterns like that because that's how most of us learn. All right. And that was kind of the idea here. As we wrote it out, we started looking for the pattern. Okay. Okay. Let's take a look at the next one, y'all. It says, which rational numbers are between 1/4 and 0.25? So the first thing I want to do, y'all, I want to convert 1/4 to a decimal. So let me get my calculator here. What's 1/4 as a decimal? 1/4 as a decimal is 0.25. Okay. So I'm first going to write up here, y'all. 1/4 is 0.25. And then the 0.25 with the bar means that I'm looking at 0.25, 25, 25, right? Now, y'all, what I'm going to do here, I know that the number after that 5 is a 0. If there's nothing there, it's understood to be a 0, okay? So what I'm going to do, y'all, is I'm going to do a little stare and compare. I'm going to look at this piece here, and I'm going to look at that piece there. If I'm looking for numbers that are between, I'm looking for numbers that are between these two. Well, those are 2s, so I can't do anything with that. That's a 5. This is a 0, and that's a 2. What number is between 0 and 2? Anybody know? If you were thinking about your numbers, 0, 2, 3, 4, what number would have to go there? 1, right? So what I'm going to do, y'all, I'm going to look for numbers that look like this, 0.251, okay? So I want to see, do I have any numbers that have 0.251? C does. So does E. And so does F, right? And again, all I'm trying to do here, y'all, is kind of think the process through, right? 0.25, I'm sorry, 1/4 is 0.25. I can always think of the number after that as a 0. 0.25 with the repeating is 0.25, 25, 25. And then we do a little stare and compare. And we say, okay, well, the only number between 0 and 2 is a 1. So I want to look for numbers that have a 0.251. And then whatever after that really doesn't matter. Okay. So notice, y'all, I'm going to do the same thing for part B. Okay. Which rational numbers are between 1/9? So first thing I got to figure out is what is 1/9 as a decimal? Okay. So let's take 1 divided by 9. Okay, 0.1 repeating, which is 0.111, right? And let's see, 0.12 repeating looks like this, 0.12, 12, 12, okay? So again, y'all, I'm gonna do the same thing here. I'm gonna do a little stare and compare. Okay, I want numbers in between these two, okay? So I know that I could say, okay, let me see, what's gonna be in between here? Let's see. If this is still a 1 there, what could go between it? 1, 1, 1, 1, 0, 1. Let me see. Let me take a look-see here, y'all, because I'm trying to figure out what's going to be in between. Those are 1s, those are 2s, those are 1s, those are 2s. Let's see. This here, 0.113, that would be bigger, so I don't want that. Okay, let's see. 0.3 1s and a 7. Well, that would be bigger. If I put a 7 here, let me see. 0.123 with a 7. 0.121. Let's see. Yeah, that's going to be in between, right? That'll be between those two. So let's go ahead and pick C. Okay. And I can probably pick F by the same reasoning. Okay. So, y'all, that's where it looks like I would stop right there. I would definitely pick those two right there. Okay. All right. Okay, and it says for the next one here, give an argument why 1/7 must be a repeating decimal. So y'all, we talked about this the other day, terminating decimals and have prime factors that are either 2 or 5. Okay, and if I notice here, my denominator here has a 7. So that's why it has to be a repeating decimal, because it's not so much of the 3, but it's the 1/7. Okay, so remember, terminating decimals, y'all, have to have prime factors of only 2s and 5s. And my prime factor here on the bottom, y'all, is a 7. So that's why it has to be that one. Okay. Okay. And so I just got a couple more problems. Actually, I think this is the last one. Yeah, this is the last one. Like I said, 7.3 is kind of a short section here, y'all. And it says, use the fact that 0.01 repeating is equal to 1/99 and 0.001 is equal to 1/999 to mentally convert each of the following fractions. Okay, this is what I'm going to do, y'all. I'm going to look at, come on, pen. I'm going to look at what I have right here. 0.01 repeating, okay? Y'all, if I were to take that number and multiply it by 44, then what I should end up with is 0.44 repeating, okay? Now, I know that this number right here as a fraction is 1/99. So this is going to be 44 times 1/99, which is the same thing as 44/99. Okay. All right. I'm going to do the same thing for the second part, y'all. I'm going to do a little stare and compare. Okay. So look, we have 0.001 repeating. Okay. Y'all, if I were to multiply that number by, let's see, 888. Okay. If I were to multiply that by 0.001 repeating, I just want to show y'all what I mean by that. Okay. So look, let me put it like this, 0.001. If I multiply it by 888, is that what I had? 888? Maybe not 888, but 880, sorry. Because I want to have a 0 at the end. So let me do it this way, 880. Okay, so look, let me take my calculator. 880 times 0.001. That's 0.88, right? And is that what I have? I have almost that. I got that part. I'll deal with the little 8 in a second, okay? But if I multiply this here, y'all, that's going to give me that's going to give me 0.880 repeating, which is what I have right here, okay? Now, we already know that 880 times 0.001, 001, y'all, repeating is 1/99. So this is going to be 880 times 1/999, okay? So that's going to give me 880 over 999. And then since I have that whole number in front, y'all, I'm just going to put a big 8 right there. And that's like our mixed number, right? So 8 and 880 over 999, okay? It's just an idea of, can you kind of see a pattern here? What am I having to multiply it by, okay? And that's probably the most challenging problem y'all have in your homework. But y'all, I want to say 7.3, there's only about 9 problems to do, so there's not a lot of stuff in there, okay? Again, y'all, when we come back next week after Thanksgiving, we're going to do one section only. We're just going to do 7.4. Y'all, if you remember at the beginning of the semester, let me go ahead and I'm going to stop recording in a second, but I want everybody to know about this because whether you're in my in-person class or my online class, it's going to look like this. Y'all, if you remember in week 4, we had a written class assignment. When we get to week 15, we're going to have one more class assignment, and it's going to be real similar to the one that we did here. So if you notice in this problem, y'all, we had like 4 questions. I want to say I've already done the class assignment. I need to look, see, make sure I did it. But I'm going to upload it to Blackboard, y'all, and I'll bring in a copy of it and everything. But let me just pull this up. There should be a class assignment 2. I may not have put it in here yet. Okay, but I'll get it. Here it is. So y'all, there's going to be a class assignment 2. It's going to have 4 questions, okay? That's going to be in the week 15 folder, okay? So we won't have a quiz on chapter 7, but there'll be one more written class assignment, and it'll be just like the way you did the first one, y'all. You can either turn it to me in person, or you can send it to me through Blackboard messages, or if you want to send it to me on Pronto, you can do that too. Just send it to me individually, right? Don't put it in the class group chat or whatever. But I just want to give you a heads up, okay? There'll be one more class assignment. Again, 4 questions, y'all. It's not a lot. And just so you know what it's going to be over, it's going to be over percents, okay? How do I go from a decimal to a percent, from a percent to a decimal, okay? And then just some basic percentage problems here, okay, y'all? So this is what we're going to do the Monday we come back, discounts and sale prices, right? And again, this is the kind of stuff that you guys would be showing your kids, especially if you have like a 5th grade or a 6th grade class, okay? So anyway, I just wanted to give you all a heads up. Let me go ahead and stop recording. And so let me stop recording.